I'm Mark,
And I'm Eric.
and this is Forensics and Beer.
Cheers.
So previously, we discussed what a digital image is in forensics. Now we're going to show how to make a very simple one. We have a nice 750 gigabyte hard drive. It was pulled from a computer. There's a Windows operating system on it. It is not encrypted. And we're going to use a free graphical user interface tool called FTK Imager by Access Data.
FTK Imager is a fantastic tool. It's lightweight. You can fit it on just about any device you want to. But the best thing about it is it's got a very simple to use graphical user interface that makes it very almost push button level forensics.
There are command line tools out there. We can do those later if you'd like, but we're going to start simple. When I say simple, the tool is very simple, and our case here is very simple. This is an unencrypted drive pulled from a computer. It only gets more complicated than that. We consider things like drive encryption, embedded storage does not pull cleanly, etc. This is simple.
Yes, and FTK tries to make your life simpler by having an easy interface for entering case data, usernames, whatever you need to record in order to keep track of what you're imaging and when.
The developer Access Data creates a lot of good digital forensics tools. FTK Imager is free. The rest of their tools are not necessarily going to be free.
So today we're going to make a physical image of a hard drive. If you remember from our last episode, physical images are the gold standards that do a bit-for-bit copy from the beginning of the drive to the very end.
Here we go. Ensure your hard drive is plugged into your computer using a write blocker. Attached a photo here of good write blocker usage. The idea of a hardware write blocker, as you see in this picture. This is a physical device that sits between your imaging computer and the hard drive that you're imaging. We can discuss write blockers later. For now, that's a hardware write blocker. It's all you need to know. Then you open up FTK Imager, you navigate up to File, Create a Disk Image. Then in this interface, you choose to create a physical drive. Then you're going to get a list of all available physical drives. This is all of the unique physical storage volumes attached to your computer at this time. That may include flash drives, and may include SD cards. In this case, we have hard drives. And I'm choosing to image physical drive 2. And you validate that it's the right size. I happen to know by looking at the label, this is a 750 gigabyte drive, and you see 750 gigabytes next to physical drive 2. You know you've got the right drive. In this interface, under Image Destination, you choose Add. At this point, you are specifying the parameters for the image you're creating. We choose RAW DD. DD literally means every bit is imaged. The 750 gigabyte drive will produce a 750 gigabyte image. No compression, no fancy stuff. Simple. Next, in this interface, you fill in the case information as you see fit and as your organization demands.
Yeah, there's a place for you to enter organizational commitments. So who's the examiner? What organization do you work for? The time and dates of when you do this, and the name of the image you want to create can all be recorded inside FTK Imager.
The next up is Image Destination Folder. That is where you want the image to reside. In this case, I have an external hard drive I plugged in via USB. I'm going to put it there. And also, next, your file name. That is the actual name of the resultant image. And then in this box about image size fragments, I'm choosing 0.
Image fragmenting was created because often we needed to store forensic images onto devices that were smaller than the drive being imaged. So we used to have to create it at 700 megabytes so that we could put those images onto CDs. Each fragment being 700 megabytes would fit exactly onto one CD at a time. and it would split whatever device you were imaging into those different fragments, up to however many you needed for a CD. So a 750 gig drive, I don't know, more CDs than I want to think about. But it's somewhat fallen out of favor as hard drive space has become cheaper, and more commonly people will do it in either 0 or just a few fragments in order to keep things simple.
Next up, we're going to skip compression and encryption. Again, we're going to make it very simple here. Next, we ensure that the verify images and the pre-calculate progress stats are clicked. Verify images creates a cryptographic hash of both the hard drive you're imaging and the image once it's made to ensure that they are the same. We're going to be discussing hashes in a future video. And pre-calculate progress stats, just that allows you to know how far you are at any given time in your image.
And it is a lifesaver, because if you don't know what the progress is, you're just going to stare and wait and hope that it says it's done successfully at some point.
Now, we really are ready to go, but before we start up, a very important question for you, Eric. What are you drinking today?
Today, I'm drinking a Heavy Seas Tropicana. It's a pretty delicious citrus IPA.
Heavy Seas is based out of Baltimore, right?
Yes, it is.
I've got a Port City porter called Robust Porter. I believe this is based out of Alexandria, Virginia.
Nice.
This is a, when I say Robust Porter, they mean it. This is excellent. All right, I think we're ready. When I click go, what's going to happen is the computer is going to reach out to the hard drive that's write blocked. It's going to read every bit and byte of data, which is going to go through the write blocker to the computer. But no commands to make a change to the hard drive can get through that write blocker. That data is one-way traffic from the hard drive to my computer, and then it passes back to my USB external drive and saves it all to this one very large file. This 750 gigabyte drive will be imaged as a 750 gigabyte file on my external hard drive. Real click start. This might take a little while. Okay, we're all done imaging, and that took a little while.
Usually does.
So let's walk through. You can see here, yes, the image is in fact done. And FTK Imager very politely presents you the MD5 and the SHA-1 hashes of both the image you created and the original hard drive. And you see on the screen that the hashes match. That validates that you've created an authentic image, that this image, byte for byte, bit for bit, is an exact representation of the original drive that we just imaged. So now we're done imaging, and from now on our investigation, we do the entirety on this image. We don't touch the hard drive anymore other than to unplug it and put it away. And speaking of which, Eric, where do we put the hard drive away?
The best place is a locked vault or some other storage area that has been designated for long-term storage. It needs to be kept under custody as much as possible, because chain of custody is very important, and these are your original drives of evidence.
So the big point here is it is very easy using a free tool to create a physical image of a drive. So long as that drive is not encrypted, it is a very straightforward process. Have fun with your beer and have fun with your imaging.
Cheers.
If you enjoyed this video or learned something, please consider liking and subscribing to the channel to be notified of future content. If you have any questions, sarcastic remarks, or beer recommendations, please leave a comment. The next video will be released whenever these beer drinking fools decide to do something worthwhile with their time.